Imagine this. Your multi-million-dollar automation line grinds to a halt. A critical failure. Production is dead in the water, and thousands of dollars are vanishing every minute. What if I told you the choice between one of these and one of these could have prevented it all? Today, we're putting cutting-edge pressure sensors up against old-school mechanical switches in a head-to-head battle for automation supremacy. We're going to find out which one you can truly trust to stop catastrophic failures in their tracks. The results will reveal a clear winner in ways you might not expect.
In automation and robotics, reliability isn't just a nice to have, it's everything. An unreliable part is a ticking time bomb that can set off a chain reaction of failures, costing you time, money, and maybe even your reputation. And when it comes to monitoring pressure, a vital task in everything from hydraulic presses to robotic grippers, you have a big choice to make. In one corner, you've got the veteran, the old guard, the mechanical pressure switch. It's a technology that's been proven on the factory floor for decades, known for its rugged simplicity. In the other corner, you have the modern challenger, the electronic pressure sensor. It's packed with smart technology and promises a whole new level of precision and intelligence. Section 1. The working principle. How they actually work? Before the fight starts, let's get to know our contenders. First up, the mechanical pressure switch. Second is the electronic pressure sensor. First up, the mechanical pressure switch. Think of this as the brute force method. Inside a physical mechanism like a dial or a piston, anti-pressure moves when preset contacts snap open or shut. It's a completely binary on or off world. The perfect analogy is a basic light switch. You flip it, the light is on. You flip it back, the light is off. There's no in between. It's simple, direct, and has a long history of being dependable in the right situations. Second is, let's look at the electronic pressure sensor. If the mechanical switch is a hammer, the sensor is an artist's brush. Instead of a single on-off tripwire, a pressure sensor is built to measure the entire spectrum of pressure. It converts a physical force into a continuous electrical signal, usually a 420 milliamp. It does this with clever tech, like piezoresistive capacitive elements that change their electrical properties as pressure flexes them. A sensor doesn't just tell you if you hit a pressure point, it tells you exactly what the pressure is right now. Think of this as a dimmer switch for a light. You can have it fully off, fully on, or at any brightness level you want. This fundamental difference, binalog, a single point versus a whole spectrum, is the key to everything that follows. Section 2, the showdown, head-to-head comparison. Alright, the stage is set, let's get to the main event. 4 rounds to crown the champion of reliability. Round 1, reliability and durability. A reliable component is one you can install and forget about. So, how do they stack up over time? Mechanical switches, for all their toughness, have an Achilles heel, moving parts. The very mechanism that makes them work, the spring, the diaphragm, the contact, is subject to mechanical wear and tear. They can be tough against pressure spikes, but over thousands of cycles, they will eventually get tired and fail. They're also prone to drifting or set point because of temperature changes or contamination, which means they often need to be recalibrated. Current sensors are built tough, often with stainless steel bodies, making them perfect for harsh environments with nasty temperature, humidity, or vibration. Plus, smart digital sensors can have built-in filtering to automatically correct for drift, keeping them accurate for way longer. For long-term set it and forget it stability, this round goes to the pressure sensor. Round 2, precision and accuracy. This is where we get it right. Reliability isn't just about not breaking, it's about giving you the right information every single time. And here, the difference is night and day. A mechanical switch is a blunt instrument. It tells you if you've crossed a single preset pressure threshold. That's it. It can't tell you if you're getting close to that point or how far you've gone past it. For some simple on-off jobs, that's fine. But in modern automation, that's like trying to perform surgery with a hammer. This is where the pressure sensor shines. It's an instrument of incredible precision. High-end sensors can offer accuracy better than 0.1% of their full scale, detecting tiny changes in pressure. They provide a continuous, high-resolution stream of data. This isn't just about getting a number. It's about understanding what's happening inside your machine. For a robotic gripper, a mechanical switch can only say, okay, I'm touching something. A pressure sensor gives the robot a sense of touch. It lets the robot grab a heavy steel firmly and gently hold a fragile wafer without crushing it. This precision is key for delicate tasks. You simply can't get that level of control from a switch. For any job that needs nuance and finesse, pressure sensors win by a knockout.
So far, it looks like a blowout for the new challenger. But what about the real world, where budgets and old equipment are a factor?
Which one have you had more luck with? Drop a comment below. I'd love to hear your war stories and which side you're on. Let's dive into round 3, cost and complexity. When it comes to the upfront cost, the mechanical switch is the undisputed king. They are simple, mass-produced, and way cheaper to buy than their electronic cousins. Installing them is also dead simple. You're often just wiring a basic electrical circuit. If your budget is the absolute number one priority, the mechanical switch looks very tempting. Electronic pressure sensors cost more upfront. The advanced tech inside is just more expensive to make. They also need a little more thought to integrate. You can't just wire them to a light. You need a brain, like a PLC or microcontroller, with an analog input that can read and make sense of the signal. That can add to the system's cost and complexity. But we have to talk about the total cost of ownership. A cheap mechanical switch might need more maintenance and calibration over its life, and when it fails, the downtime can be devastatingly expensive. An electronic sensor, while pricier at the start, can dramatically cut down on maintenance and prevent that costly downtime with its higher reliability. So, while the mechanical switch wins on sticker price, the pressure sensor often delivers way more value in the long run. Let's call this round a split decision. Round 4, failure modes, preventing catastrophe. This is the most important round of all. How a part fails is often more important than how it works. This is about stopping those system-ending disasters. When a mechanical switch fails, it often does so silently and completely. The contacts can get welded shut, a spring can break, or a piece of dirt can jam it up. The result? A switch that's either stuck on or stuck off with no warning at all. This is what's known as a dangerous and undetected failure. Your control system thinks everything is fine, but in reality, your hydraulic press is about to overpressurize or your robot is about to drop a 1,000-pound part. This is where an intelligent electronic sensor becomes a lifesaver. Of course, sensors can fail too from an electrical overload or serious damage, but their failures are often more predictable and less sudden. Instead of just dying, they might start to drift out of calibration, a change your control system can spot. If the PLC sees a pressure value that's physically impossible or hasn't changed in days, it can flag an error. Sensors even have built-in self-diagnostics that warn you about a problem before it causes a failure. And PLC display should show an error message. The failure of a sensor is often a call for help. The failure of a sensor is often a call for help. The failure of a mechanical switch is often just silence. For preventing a catastrophe, pressure sensors are the responsible choice.
The verdict. Which one should you trust? The modern choice delivers reliability and innovation. So, after 4 rounds, who's the winner? While the pressure sensor clearly took most of the rounds, it's not a total knockout. The truth is, the best choice is the one that's best for your specific job. So here's a simple framework to help you decide. Choose a mechanical pressure switch for tight budgets, simple applications, and easy installation. You should choose an electronic pressure sensor when reliability, uptime, and preventing catastrophic failure are your absolute top priority. Your application is dynamic, high-speed, or requires delicate control, like most things in modern robotics. The system operates in a tough environment with vibration, temperature-built, a smart system with remote monitoring, data logging, and predictive maintenance.
If this breakdown helped you make a better decision for your next project, do me a huge favor. Hit that subscribe button and ring the bell so you don't miss our next Tech Showdown.